What if the most profound question humanity has ever asked, are we alone, finally has an answer? Imagine a world 120 light-years from Earth, holding the unmistakable chemistry of life. A planet whose air breathes with the same molecular whispers we find only in living systems. Scientists now say there's a 99.7% probability, almost beyond doubt, that something alive might already exist out there. This is not hopeful speculation or science fiction. It's a revelation emerging from photons captured by a mirror a million miles from home. The most powerful eye ever opened to the universe. The James Webb Space Telescope, a single molecule, dimethyl sulfide, a compound known on Earth to come only from the metabolism of living organisms, has been found drifting through an alien atmosphere. Every signature, every pulse of light, every ratio of gas points to one astonishing truth. Somewhere, far beyond the solar system, life may have already taken hold. The planet is called K2-18b, orbiting a small red star in Leo. Its environment, temperature, and chemistry all defy what we thought possible. This isn't Earth's twin. It's something new, an entire category of habitable world that could be more stable, more enduring, and even more welcoming to life than our own. Tonight, we'll uncover how Webb's golden mirrors became humanity's new sense for life, decoding signals that have traveled for more than a century through empty space. You're about to witness the moment when the universe itself whispered, with unprecedented clarity, "You are not alone." Deep in the constellation Leo, 120 light-years from Earth, the James Webb Space Telescope captured something extraordinary. A discovery that may rewrite the boundaries of biology and the universe itself. On a Tuesday morning in December, astrophysicist Niku Madhusudan at Cambridge University noticed an anomaly, a chemical in the data that should not exist without life. The molecule was dimethyl sulfide, DMS, a substance on Earth produced by plankton, soil microbes, and marine life. It doesn't come from lightning, volcanoes, or mineral reactions. Only biology makes it. And this time, the signal wasn't faint. It was distinct, statistically strong, and verified across multiple Webb instruments. The numbers were staggering. A 99.7% probability, a level of significance known as 3 sigma in the scientific world, meaning only a 1 in 1,000 chance of being wrong. In physics, this level of certainty is reserved for discoveries like the Higgs boson or gravitational waves. This wasn't wishful thinking. It was data, precise, repeatable, and impossible to ignore. The world producing this signal, K2-18b, orbits a small, cool red dwarf known as K2-18. The star glows with a steady, deep red light. The planet's size is about 2.6 times Earth's radius and about 8 times its mass. Large enough to hold a thick, hydrogen-rich atmosphere, but too small to become a gas giant. Once dismissed as inhospitable, Webb's observations revealed a surprise. Below the thick hydrogen layers, temperatures are steady at 49 degrees Celsius, 120 degrees Fahrenheit. Warm, but ideal for liquid water. This balance makes K2-18b the best-known example of what scientists call a Hycean world. A planet with vast oceans and a hydrogen envelope that maintains stability across time and climate. The James Webb Telescope orbits the Sun at Lagrange point 2L, 2, a million miles from Earth, shielded by a 5-layer sunshield, colder than Pluto. Its 18 golden mirrors, each a precisely engineered hexagon, can detect heat equivalent to the warmth of a bumblebee on the moon. When K2-18b passes in front of its star, a fraction of light from the star filters through the planet's atmosphere. Webb's spectrographs detect that filtered starlight, splitting it into a fingerprint of wavelengths, a pattern that reveals exactly which molecules are present. Those patterns showed water vapor, carbon dioxide, methane, and then most astonishingly dimethyl sulfide. For scientists, the most shocking revelation wasn't just the presence of molecules associated with life, but their stability in disequilibrium. On a dead world, methane, water, and carbon dioxide would balance into a chemically neutral state. But K218b's atmosphere isn't balanced, it's dynamic, fluctuating alive. This is the clearest chemical hallmark of a biosphere, an environment perpetually reshaped by metabolism. Even the planet's absences told a story. If it were lifeless, its air would be saturated with ammonia, a natural byproduct of decay. Yet ammonia was nearly missing, as if something were consuming and recycling it, another clue to ongoing biological activity, just as microbes do on Earth. Astronomers call the 3 sigma detection of DMS the strongest evidence yet for extraterrestrial life. But they remain cautious. Though most molecules can form abiotically, dimethyl sulfide on Earth is only created by living cells, primarily by marine organisms. Webb's data has inspired excitement, but also skepticism, as further observations are needed to reach a 5 sigma confidence level, the gold standard of scientific proof. Upcoming Webb sessions planned within the next 2 years will target new wavelengths to confirm the molecule's persistence and rule out alternate chemistry. If confirmed, this discovery will mark humanity's first measured evidence of alien biology. The red dwarf K2-18 itself is a marvel of longevity. Smaller and cooler than our sun, such stars can live for trillions of years, burning steadily without major flares. This constancy means their planets enjoy near-eternal stability, stable warmth, consistent energy, and calm conditions where evolution can unfold uninterrupted. K2-18b orbits its star every 33 Earth days, always keeping one side bathed in daylight and the other in perpetual night. The result is a world of eternal twilight, a planet divided by a ribbon of gentle copper light stretching endlessly across its surface. Beneath its red sky, heat moves evenly through its dense hydrogen atmosphere, ensuring that oceans neither freeze nor boil. Balance, the rarest gift in the universe, reigns here. To the human eye, standing on K2-18b would be surreal. The horizon would curve beneath a rose-tinted sky. The star would hang motionless above the horizon, glowing softly, never setting. Oceans would shimmer under crimson clouds, their waves reflecting dim auroras that flicker faintly across the planet's shadowed side. In those dark waters, chemistry itself becomes art, hydrogen blending with water to create exotic seas, able to remain liquid across extreme ranges of temperature and pressure. Pressure here is immense, hundreds of times greater than Earth's oceans. Yet such force could stabilize molecular structures, protect fragile compounds, and allow biology to thrive, despite the alien conditions. Just as on Earth, where life emerged in the crushing darkness of deep hydrothermal vents, life on K2-18b could be born from chemistry, not sunlight driven by energy from within. Hydrogen and carbon interacting under heat could form the building blocks of cells. Billions of calm, steady years would allow those primitive molecules to evolve beyond imagination, slowly, patiently, uninterrupted. If microscopic life exists in these oceans, its effects reach upward. The methane-water-carbon cycle, measurable in the air, shows feedback gases produced below, released into the atmosphere, then consumed, recycled, and stabilized. Each molecule that Webb detects, traveling across 120 light-years, is evidence of equilibrium. The same equilibrium Earth maintains through photosynthesis, respiration, and decay. Some researchers believe there could even be microbial clouds, colonies of airborne organisms drifting through the denser layers of the atmosphere, much like plankton float in Earth's seas. In that layer, where temperature and pressure resemble Earth's, life could exist freely suspended, feeding on trace chemicals and filtered light. That faint mist Webb captured, those fragile photons, are not just data, they're messages. Light encoded with the breath of another biosphere. For centuries, humanity has looked up and wondered whether the stars were silent. Now, the silence is breaking, because if K2-18b, a hydrogen world around a tiny red sun, can host life, then life isn't unique. It's inevitable. 3/4 of the stars in our galaxy are red dwarfs, each with their own planetary systems. If even a small fraction host worlds like this one, then the Milky Way could be overflowing with oceans, clouds, and biology. This discovery doesn't just expand astronomy, it expands imagination. It redefines what habitable means. It blurs the line between chemistry and life, between observation and connection. The Webb telescope doesn't just photograph light, it listens to existence. Each photon it collects is a syllable in the universal language of life. And the message is clear. Life does not cling to fragile conditions. It thrives wherever balance permits. It's not the exception. It is the rule. Every star we see could harbor its own living seas, its own breath, its own stories folded into the fabric of time. When the next generation of telescopes, NASA's Roman Space Telescope, LUVOIR, and HABEX, turn their mirrors toward these worlds, we may one day see continents, clouds, and oceans directly. Humanity will no longer be an isolated species on a small blue dot. We'll be one voice in a cosmic chorus, ancient and ongoing, the universe itself made self-aware through us. The James Webb Space Telescope has shown us a truth we always hoped but never proved. The cosmos is not silent. It is alive, and somewhere under crimson skies and endless seas, life calm, patient, enduring is waiting for us to listen. This is not the end of our search. It's the beginning of a new chapter, the moment astronomy becomes biology, and the sky above becomes a living map of existence. As Webb continues to gaze into infinity, every flash of light it captures brings us closer to understanding the truth written across the stars. Life is not a miracle, it's a pattern. If you like the video, don't forget to leave a like and subscribe. It makes a huge difference and helps the channel.